Okay, kids, here we go. Unit 5, Lesson 6. Unit 5, Lesson 6 is all about taking these solids that we've been talking about, and now what we're going to do is we're going to apply scale factors. So we're going to scale them, we're going to make them bigger, we're going to make them smaller, and we're going to see what is the relationship between the scale factor and the actual volume we get and the actual surface area we get. So here we go. Unit 5, Lesson 6, Problem 2. We're going to use, first we're going to use unit cubes to build cubes that result from dilating a unit cube by each scale factor shown in the table. Then we're going to complete the table with the surface area and the volume of each dilated cube. So first of all, since we're not in the physical school building, and I'm assuming that you guys do not have unit cubes kicking around, what I'm going to do is I posted this link on the Google Classroom, and if you click on this link, it takes you to the Illustrated Math website. It takes you to the online lesson. If you just scroll down, there's a GeoGebra app built into the lesson that has unit cubes, and we are going to come down here to these sliders, and we're going to change. This is how we're going to change our scale factor. So we do have unit cubes, we just can't hold them actually in our hands. It's going to be virtual. So first of all, we want to talk about the surface area in square units. So if we come over to our cube, our unit cube, here it is, we want to talk about the surface area. Now the surface area, remember, is just the area on the outside of a three-dimensional figure. So let's look at it one side at a time. So how do we find the surface area of one side of a cube? Well, a side of a cube is just a square, so it's the length times the width. So if we come back here, I know the surface area is going to be the length of 1 times the width of 1, right? But when we go back to our unit cube, this 1 by 1 is just one side of this cube. So how many 1 by 1s do we have here? Well, we have the front, the back, the two sides, the top and the bottom. So we actually have 6 sides of the cube. So we got to take this 1 by 1, and then we have to multiply it by the 6 sides. So the first surface area we have is 6 square units. Now let's look at the volume. So how do we find the volume of a cube? Well, the volume of a cube is just the length times the width times the height, right? So the length times the width times the height. So if we come back here, I know our volume is going to be the length, which is 1, times the width, which is 1, times the height, which is 1. 1 times 1 times 1 will give us 1 square unit. Perfect. Now let's move on to a scale factor of 2. So we're going to come down here to the sliders, and we're going to make it 2 blocks long, 2 blocks wide, and 2 blocks high. Let's talk about how that changed our surface area. So notice, look at the area of one side. It is now 2 by 2. 2 by 2 for one side, but remember, we still have those 6 sides. So it's 6 sides, and each side is 2 by 2. So 2 times 2 is 4. 6 times 4, my surface area is 24 square units. So units squared. Now let's look at our volume. The volume again is length times width times height. Length times width times height. And it is 2 units long, 2 units wide, and 2 units high. So then my volume is 2 units long, 2 units wide, 2 units high. 2 times 2 times 2 is 8 units cubed. Let's go down to a scale factor now of 3. So let's increase it to 3 units long, 3 units wide, 3 units high. Again, surface area is going to be like just this front side, which is 3 by 3, and we have 6 of those. So we have 6 of these 3 by 3 sides. So 3 by 3, 3 times 3 is 9, 6 times 9 is 54 square units for my surface area. Let's look at what happened to the volume. Length times width times height is 3 times 3 times 3. So 3 times 3 times 3 is 27 units cubed. Last one we have is a scale factor of 4. So we're going to make our block 4 by 4 by 4. Notice what happened to the area of one side. The area of one side is now 4 by 4. So we have the area of one side is 4 by 4, but remember we need to multiply that by the 6 total sides. 4 by 4 is 16. 6 times 16 is 96 square units. Let's think about our volume. Our volume now is going to be 4 length, 4 width, and 4 high. So 4 times 4 times 4. And that will equal 64 cubic units. So here's our table. The values that we are most interested in for the surface area is the totals here for surface area, and the values that we're most interested in for volume are right here, the total volumes. Okay, so let's come down here, and it's asking us to write an expression for the surface area of the dilated cube. Well, realistically, what we want to do is we want to somehow compare our scale factors. We want to compare these scale factors with the surface area that we got. And notice what we did is we had to take the scale factor and multiply by itself each time. And we call that squaring. But then we had to multiply it by the original 6, okay, because there were 6 sides. So the expression for the surface area would be the 6 sides times whatever the scale factor is squared. Now let's look at an expression for the volume of the cube. So notice, for the volume of the cube, we come over here and look at our scale factor. And what did we have to do with the scale factor each time? What did we do with that scale factor? Well, for the volume, all we did was we took the scale factor and cubed it. Now, let's compare and contrast these. So the expression for the surface area, I notice the surface area has a 6 for the 6 sides. Okay, And then the area of each side was just the scale factor squared. Okay? And that's how we got the 6 times the k squared for 6k squared. Well, let's look at the volume. I notice the volume original is just k cubed. Why is there no coefficient here for the k cubed? Well, there actually is. The original volume is 1. So we can really think, and then we're going to multiply that, then multiply that by the scale factor cubed. So my volume, if you really think about it, is the original 1 times k cubed. And notice up here in my expression, whenever we don't see a coefficient in front of the variable, it's understood to be a 1. So that's really just like 1 times k cubed. Okay, so here we go. What we've done here is we've kind of come up with some general ideas of how the scale factor can affect surface area and volume.